This is our third tutorial in which we are going to learn the smoke flow in the environment. Basically, it is very simple simulation, and most of you guys have seen this problem in your life. In the industrial area, lots of harm gases are produced in the industry that has to be discharged from the industry in the at some height to avoid the damage to the surrounding area of the industry. So for that we use the chimney, so we can discharge the smoke at some height that will eventually disperse into the environment. So today we are going to see the impact of air velocity on the smoke flow, and also we will see the effect of the velocity of the smoke and air that is coming from the chimney. So let's see the overview the problem. So if we see, this is our domain. This total height of our domain is 10 meter and diameter is 20 meter. So the velocity basically is being acting in the x direction. You can see the arrows in the black at a speed of 1 meter per second. That is the wind speed. And we have created these two small openings. Sorry, these two openings that are being acting as the pressure opening, and the pressure is absolutely atmospheric pressure. Also, the smoke is coming out from the chimney at the rate of 0.01 meter per second to 0.2 meter per second. So it is very interesting tutorial, and you will learn a lot in this tutorial. So what we are going to learn, how to create the expressions in the CFX, and then we will see how to create the additional variables in the CFX to accommodate the smoke flow in the air. Also, we will see how to run a time-based simulation in the ANSYS CFX, and in the results section we will see how to create the scene animation and other results, and how to save the results in the form of PNG or the animation in the video format. So if we talk about the expressions, we have to use two expressions, one for the velocity of the circular vent and other for the smoke variation. So we will see both of these in the CFX. Also we will see how to plot the vector results in the post CFD and how to create the isosurface. So let's start. First of all, we have to drop down the CFX from the toolbox. So right click on the meshing, import mesh file. I will provide the source file in the description. You can download it and practice the tutorial. So now come to the setup. So delete the default domain, come to the additional variable, right click and insert additional variable. Name is at smoke. Click on OK. We have to provide the unit, which is kilogram meter per cube. Click on OK. So we have created this additional variable. Now we have to come to the expression. Click on insert, write times constant. The value is 30 seconds. Click on apply. Now again insert an expression and create the final concentration. One kilogram. Provide the unit. One kilogram per meter cube. Okay, click on apply. We have created two expressions. Now come back to our smoke concentration. So we need final value, time constant. So let's define, these are the two constants which were being used in our expression. So I have created the separate equation for each of them. So if I want to change the final concentration or the time constant, I will just come to this and will change it. So now create a new expression, smoke concentration, click OK. Now I have to add the expression that is I have created earlier. Now multiply, use ABS. So why I am being using ABS? Basically ABS will convert the value to plus whatever will be the value that we are getting in the equation. It will always take a positive value of the parameter, so we will never get the negative value. So minus t, so that is time constant. Click apply. Okay, if we plot it 30 seconds, so you can see the smoke is being decreasing with the time. This is why, because I did not add the minus sign here. Also forget to add the exponential. Click on apply again, come to plot. So now you can see the smoke concentration is increasing with the time. Also I can evaluate it. So what if I will not use this ABS function? What will happen? Let's see. It does not affect in this case. And if I, okay, it's fine. Okay, we have created our smoke concentration equation. So let's create the other equation of velocity. Okay, so what we have to provide, the initial velocity is basically 0.01 plus the final velocity is 0.2 minus 0.01 multiplied by t. So if you see, there is an dimensional error. So to eliminate that, I have to provide the dimension. Click on apply, evaluate it again. So now the error is being resolved. Okay, we have created both of the equations. Okay, it's fine. So now the velocity will increase with the time. Also we have to create another equation because we have to limit the velocity after 1 second to 0.2. So to do that, click on expression, velocity. Okay, we have to use a function if command. If t is less than 1, velocity will be this, otherwise it will be 0.2. So let's plot it. So there is a small error that we are not using the time dimension. So I just have provided this. So now if we go to the plot and then define plot, okay, so you can see after 1 second the velocity become 0.2 and then it will continue to 0.2 second. So now let's come back to the outline. First of all, we have to create a domain, name it as float with smoke. Click on OK. Come to location. There is only one location, so click on it. We are using air, it's okay. Stationary, we can turn on the gravity minus 9.81. No, in our case the gravity is basically working in the z direction, minus 9.81, it is 0. 300 Kelvin. Okay, come to the fluid domain, provide the kinematic diffusivity. The kinematic diffusivity is 1. Click on apply. Okay, now it's fine. I'm using the transport equation, or we can use the diffusive transport equation. So we have defined the default domain. Now we have to define the boundaries. Smoke inlet, we have to select the location, which is event. Now come to the boundary condition defined by expression, and we have the expression of this. Also this is defined by the expression smoke concentration. Okay, so all done. Click on OK. Now we have to provide the wind inlet. Come to the boundary condition, change to the Cartesian component. The velocity is acting in the u direction. The additional variable, that is the smoke, the value is 0 at the wind side. So click on OK. So now we have to create the boundary opening, that is atmosphere. Click on 0 relative pressure and 0 additional variable value. Click on OK. So the boundary conditions are defined. Now come to the analysis type. Click on transient. Control it by expression, time constant. The size is, let's take 0.1 second. So the analysis will be completed in 300 time steps. Okay, we have also defined it. Now come to the output control, and we have to see define the results. Click on OK. I am changing to the selected variables, so I can choose the variables that I need in the output. So I need velocity in the u direction, vorticity, velocity, pressure, smoke, the viscosity, and the turbulent kinetic energy. So you can choose the desired output variables from here, and it will save a lot of space in your computer, because each variable will take space as the result file. So by decreasing the number of variables, the space that you are needed in your hard drive also will reduce. Also I have to select the time step. I am selecting the interval to the 5. So every 5 time steps the results will be saved in the output. So Click on OK. All done with the setting. Close the window. Come to the solution. We have to define the run. Click on double precision. Yeah, one thing we forget is to define the initial condition, because we are running the transient simulation. So insert, so you can select it from here. Okay, the initial conditions are these. You can see the 1 meter. Okay, click on OK. Okay, there is no error. Close the window. Click on double precision. I'm going to use 10 of my processors. Initial condition, start run. So let's wait for the completion of the simulation, and then we will see the results. Okay, the simulation is being completed now. You can see we get a converged solution and there is no disruptions. Now let's come to the result section. So we will see how the smoke is being dispersed in the environment. So let's define isosurface. Change the variable to the smoke. Now I am going to take the value of 0.05. Come to the boundary conditions. So if I run the simulation, you can see the results. Okay. Also we can see the other variables. Okay. Click on the isosurface and smoke. Okay, total. Click on total pressure. Change the value to forget about it, because there is click again on the smoke. See the values. So there is no much. You can see the difference in the flow smoke. Let's define a plane. The gx, it's fine. Color it by variable. I want to see the smoke. So you can see the values of the smoke. If I change the time, so there is not a significant difference with the time. Also, if I see the velocity, so you can see this, the change in the velocity. You can also see the total pressure and turbulent kinetic energy. No, it's fine. Yeah. So you can see this turbulence. Also, it doesn't record. Okay. If we click on the global, and now basically the turbulence is being occurring behind the cylinder, or you sorry, the chimney. So now let's come to the ISO stream and start it from the smoke inlet. So you can see the direction of the smoke, and it's provide lots of results about the stream, the flow path, and we can see that if we see at the start, the streamline are in the horizontal direction, but by increasing the concentration of the smoke and the increasing the velocity of the air, but the main impact is due to the concentration of the smoke. The flow path is going, you can see the flow path is going downward, which is a negative sign, because in this case the smoke is going does not going upward in the environment, in the environment, but it is going into the surrounding area of the chimney, so that is not good. So we it's recommending that we have to change the geometry or to increase the flow rate of the air through the chimney. So in the short, it's providing us the design inside, so we have to increase the height or do some change some other parameter, so it does not happen. So by doing this, we can get a lot of, you can see the, sorry, I want to say that the simulation provide a lots of insight about the design. So now see how to save the results. Like I want to save the streamline, so come to start, save movie, come to option, you can change the quality of your video. I am going to select the 1080p result. Also I'm going to use the white background. If we go to the advanced, I'm going to decrease, or okay, 24 frame rate per second is fine. Click on OK. I want to save it in MP4, and let me define the location to the documents here. Define the name to streamline. Click on save button. Sorry, there is a little bit noise in the background, avoid that. Okay, click on the play button, and it starts saving the animation. Also, if I want to create the vector, to create vector plot, I have to define the location. Let me define the plane one. Click OK. So you can see the results. If I at the start, the direction of the wind is in horizontal. After time, you can see the wind direction is changing. If I play it, let me change the name to the vectors. Now uncheck the save movie, so you can see the results. So I can see my results are being saved. We will check it in a while. Let me come to the vector plot again, and I can see the 3D plot of the vector. I just have to change the domain. No, 1 second. So you can see here are the, I am going to change it to maximum points and change the value to 750. So now I can see the 3D flow path of the vectors. So now we will see the volume rendering. Click OK, change it to smoke, click on apply button, change the resolution to 200 and transparency to 0. So you can see the flow. Let me, okay. So this is the volume rendering. Now come back to streamline. And for example, if I want to save the streamline, let me also change the symbol. Instead of line, I am going to use a tube, or I can use a ribbon. So it's look fine. Now come to this camera option, and you can see I have to select the location. Let me come to the document tutorial, and now streamline image, click on save. You can also save it in other formats. I'm going to use the white background. Also, if I use the 1000% scale, so the image will be saved in 10 times more accurate as compared to our screen resolution. Click on save button. It will take more time. We see this image that we have saved earlier. So you can see the resolution of the image. You can see it's very high resolution because I have saved it 10 times to my screen resolution. So you can see the quality of the image is very nice, but do not try it on a low specification computer or laptop, otherwise it will hang your laptop or computer. So if we see the video, it is in 1080p quality, and you can see it's not that fine. If I play it, I can see the flow over the time. So thanks a lot, guys. Hope you have learned a lots of new things in this tutorial. We'll see you in the next class. Goodbye.